Hi all the students. Today we are going to study frequency division multiplexing. So basically these are multiplexing techniques. It is also known as FDM. FDM stands for frequency division multiplexing. Now throughout a range of frequencies or throughout a frequency spectrum, there are different channels that we want to use. Like this is channel 1, channel 2 and channel 3. So the frequency spectrum that is used by channel 1 is from 60 to 64 kilohertz. Then the frequency spectrum that is used by channel 2 is 64 to 68 kilohertz. And then the frequency spectrum that is used by channel 3 is within the range of 68 to 72 kilohertz. So now here you are seeing that there are three different channels and all three of them are utilizing a different range of the frequency spectrum, right? So one is between 60 to 64, 2 is between 64 to 68 and 3 is between 68 to 72. That means since they are using different frequency ranges, they can be multiplexed, or they, like here you can see diagrammatically we are showing how the three channels are multiplexed and sent through the same transmission line. Because they are using different frequency ranges, hence they are not interfering with each other, hence we can combine or multiplex them together and send them at once through the same transmission line. So the transmission line is same, but the frequency spectrum or the frequency range used by each channel is different. So there is no interference of one channel with the other. So this is your channel 1, this is your channel 2 and this is your channel 3. So channel 1 is basically using frequency ranges between 60 to 64. Then from 64 to 68, this frequency range is used by channel 2, and the frequency range 68 to 72 kilohertz is used by channel 3. So all three of them are using different frequency ranges, hence no one is interfering with any other channel, right? So we can multiplex or combine them together like this, and then we can transmit them using the same transmission line. So this is all multiplexing is about. And when we talk about frequency division multiplexing, that means we are basically dividing the frequencies. The term itself says frequency division. So that means dividing the frequency ranges into different ranges. So one range is used by one channel, another range is used by another channel. So since different channels are using different frequency ranges, hence they can be multiplexed together. So basically you are dividing the frequency ranges and each range is then being used by other channel, right? So this scheme is basically used around the world, and to some degree this is standardized. That means standard frequency division multiplexing technique is used throughout the world. Now usually 12 4000 Hertz voice channels are multiplexed into 60 kilohertz to 108 kilohertz of ranges, right? So the one voice channel utilizes 4000 Hertz of frequency, and 12 such channels are combined or multiplexed, and they then use the frequency between ranges or between the frequency range of 60 kilohertz to 100 kilohertz, right? I'll explain it through a diagram. See, as I said, there are 12 such channels. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 such channels. Each channel has a frequency of 400 Hertz, right? And they are within the range of 60 to 100 kilohertz. That is, the frequencies are divided for 12 such channels, and the starting to ending range of the frequency is from 60 kilohertz to 108 kilohertz. So like here you can see it starts from 60 kilohertz and ends at 108 kilohertz. And between this frequency, the frequency range has been divided into several such frequency ranges, like from 60 to 64 kilohertz, then from 64 to 68 kilohertz, then from 68 to 72 kilohertz, then from 72 to 76 kilohertz, then from 76 to 80 kilohertz, from 80 to 84 kilohertz, from 84 to 88 kilohertz, then from 88 to 92 kilohertz, from 92 to 96, and 96 to 100, 100 to 104, 104 to 108. So 60 to 64, basically 60 to 64 kilohertz means 4000. It is basically a frequency range of 4 kilohertz. 60 to 64 makes a range of 4 kilohertz. Hence it is 4000 hertz. It is equals to 4000 hertz. And as said, every channel occupies 4000 hertz. So this is exactly 4000 hertz, which is occupied or utilized by each channel. 60 to 64 makes it 4 hertz. 64 to 68 again 4 hertz. 68 to 72 again 4000 hertz. I'm sorry, not 4 hertz, 4000 hertz. So from 60 to 64 it is 4000 hertz. Then again from 64 to 68 it is 4000 hertz. And again from 68 to 72 it is 4000 hertz, and so on till 108 hertz, kilohertz, right? So basically 60 to 64 makes it 4 kilohertz, and 4 kilohertz is equals to 4000 hertz. So that is what we are saying. Each channel is using 4000 hertz of frequency. So this way the entire channel, an entire frequency spectrum is divided into 4000 hertz of frequency range, and each 4000 hertz of frequency range is being occupied by each channel, but they are divided into different frequency spectrums. Like 60 to 64 is one spectrum, 64 to 68 is one spectrum, 68 to 72 is one spectrum, but all of them have the same range, that is 4000 hertz. So such different frequency spectrums having the same frequency range of 4000 hertz, having the same frequency of 4000 hertz is occupied by each channel. So 60 to 64 makes it 4000 hertz occupied by channel 1. 64 to 68 makes it 4000 hertz, again occupied by channel 2. 68 to 72 again makes it 4000 hertz, that is occupied by channel 3, and so on. It continues till the frequency of 108 occupied by channel 12, right? So this is how basically 12 voice channels are multiplexed together, each channel having a frequency of 4000 hertz, occupying different ranges in the frequency spectrum. So this is how 12 voice channels are multiplexed, so into a frequency range of 60 kilohertz to 108 kilohertz, right? Now this unit is called a group. That means such 12 channels which are occupying a frequency, which have a frequency of 4000 hertz and occupying the frequency bandwidth between 60 kilohertz to 108 kilohertz, such voice channels multiplexed together are known as your group, right? And 5 such groups can be multiplexed. 5 such groups of 12 channels each can be multiplexed, and when they are multiplexed together they are called the super groups. And 5 or 10 such super groups, again such 5 or 10 such super groups when combined together form the master group. So this is basically how the channels are how different channels are multiplexed. Now basically in frequency division multiplexing, 3 voice grade telephone channels are multiplexed, right? There are 3 different voice grade telephone channels which are multiplexed using FDM. Now when many channels are multiplexed together, so in that case 4000 hertz is allocated to each channel. As we saw just now, each channel was, out of all the 12 channels, each channel was occupying exactly 4000 hertz of the frequency band or frequency range. Like, so this way they keep it keeps them well separated. They are well separated this way, and none of them interferes with the other. Now first the voice channels are raised in frequency, right? The original frequency is raised first of all, and then obviously by a different amount so that they do not interfere with the other channel. So the frequency of all the voice channels are raised, but by different amounts so that they do not interfere with each other. And then after that they can be combined, right? Because they have different frequency ranges, so then they can be combined, which is actually the concept of multiplexing, because no two channels now occupy the same portion of the spectrum. They are all occupying different portion of the spectrum. Hence, none of them can interfere with each other. So, they are then combined or multiplexed together and sent through the same transmission line. Now, although there are gaps or guard bands between the channels, but there is still some overlap between the adjacent channels because the filters do not have sharp edges. Like here you can see here, though they are well separated, but they have at the edges they are overlapping, right? So like 60, it ends, channel 1 ends at 64 and channel 2 starts at 64. So at the ends, so basically there is some overlap at the adjacent channels because one channel is ending at 64 and the other channel is starting at 64. So obviously there will be some overlap in such case between the adjacent channels. So this overlap basically means a strong spike at the edge of channel. So usually at the edge of the channels there is a strong spike, and this can be felt in the every adjacent channel as a non-thermal noise. So this is all about frequency division multiplexing.